Hope my video and audio are visible. You guys can either unmute yourself and answer, or you can put the chat also. Meanwhile, I'm sharing. Is my audio and are you able to hear me? Anyone can reply. Okay, thank you, Dhanushri. Okay, so now I'll be showing my presentation, so I will not be able to see your chat messages or other reactions. So if you want to stop me in between or say anything, I think the only way is you guys will have to unmute yourself and say, okay? Okay. So, okay, more people are joining, it's okay. So I'll start sharing my presentation now. Is the slide visible and the slides are changing also? I'm not able to see. So somebody will have to answer. Is it changing? One of you can take the initiative and reply me, please, because otherwise it's currently. Yeah, I was just. Okay, thank you. But Josh, what I was saying is when I'll be presenting my slide, it will be taking my entire screen. So if you, I won't be able to see your messages. So in between, if you guys will have any questions or you want me to stop, you will have to unmute yourself and say, okay. I hope that's clear now. So I'll start our today's session. Make it full screen. Okay. Uh, Once again, good afternoon to everyone who has joined for today's interactive session. It is the second interactive session for the NPTEL course Experimental Physics 1, which is being taken by Professor Amal Kumar Das. I am the teaching assistant. My name is Renalini. I am a research scholar, PMRF research scholar from School of Physics, University of Hyderabad. So, in case if somebody has joined today for the first time, so this interaction session will happen every Saturday from 3 p.m. to 5 p.m. that is for 2 hours. So it is scheduled every Saturday, and today is the second interactive session. So last week, at the end of the session, somebody had asked about the recommended book for this course. So actually, by the instructor, Professor Das, there has not been any specific book recommended. Like if you will go to the course website where you watch those lecture videos, you will see there is one book provided there. I don't know if today Aditi has joined or not. Last time she had given link to that for she had shared that link with us. I checked that link out, but I found out that it's not actually a book. It's a video transcript of the lectures of the video lectures that the Professor Das is taking. So they are just like what we say. I mean, video transcripts they are. So it's not a book, and he has not recommended any other book. So what I thought is, few things I am seeing, especially like in last 2 weeks or the coming third week also, they are mostly from our NC like class 11, 12th concept mostly they are covering. So I found out the appropriate uh, study material for these 2 weeks lecture, especially NCRT class 11th physics book, chapter 1 or 2, actually depending on the PDF. Some PDF has in chapter 1, some PDF has chapter 2. So those books have some content related to relevant to these lectures right now. And what else I can do is, if I'll find some relevant PDF, I'll share the same with you. I think you guys have already seen that all the sessions recorded video and these presentations that I am making, I'm up after the end of the session we are uploading it on Drive, where you can access them anytime. So I will upload these relevant PDF or study materials there. I think there, from there you can access these things. So whatever I'll come across, I'll be uploading it there. So okay, so starting with our today's session, last week we had seen and the lectures were about the basic tools and apparatus that we see in a laboratory. These were the things that we had discussed last time, and we had in detail discussed what is the use of screw gauge and vernier caliper, and how do we take any measurement using these two, and how to calculate their least count and other things. So in this week's lecture, as the professor had talked about some other basic tools and apparatus in the laboratory, which were galvanometer. This is the image of the galvanometer, meter and voltmeter. This is also a voltmeter, it's a little modern version. So I mean, these are the two terminals, positive and negative terminals, using which we connect these devices in a circuit. So this is a little modern version where we cannot directly see these kind of positive negative terminals. Maybe it is at the back or somewhere, but these are little old versions, and this is a newer version. That's it. So we'll talk about galvanometer, ammeter, voltmeter, their use and how their working is a little later. I hope you guys remember this thing. Last time we had discussed that whenever we carry out any measurement, that whatever value we obtain from that measurement, we want to know if how much we want to understand if that value is accurate or not, if it's precise, how much precise it is. Like we had seen that using our usual 15 centimeter scale, its least count is 0.1 centimeter, whereas the least count for vernier caliper is 0.1 millimeter, and for screw gauge is 0.01 millimeter. So I mean, we get more and more precise value if we measure something using vernier caliper. So all these things we had discussed last time. I'm just giving you a recap. And okay, so now starting today, we'll discuss about whenever we carry out these measurements and find out some value, then there comes another aspect that is called significant figures. Okay, so for example, say that I have measured length of some rod. Say I have measured length of some rod. It comes out to be, using some instrument I have measured that its length comes out to be 23.65 centimeter. So when we talk about the significant figure, okay, so significant figure, it's also called significant digits. Like how many digits in this particular value of measurement are significant. So what do we mean by significant digit is, so significant digit includes reliable digits plus first uncertain digit. So whenever we carry out this measurement, we know that different devices have different least count, right? Like least count of vernier caliper is 0.1 millimeter. Uh, or least count of, this is for vernier caliper, least count of screw gauge is 0.01 millimeter, which means 0.001 centimeter. So I mean the precision it will give is up to 3 decimal digit. So here we see it's up to 2 decimal digit. That means maybe the instrument used is a vernier caliper and we are getting the precision up to 2nd decimal digit. Now how many digits in this is significant? So what do we mean by significant is how many digits are reliable and how many digits are uncertain. So when we take vernier caliper reading, if you remember, the total reading there is main scale reading plus vernier scale reading into the least count and minus 0 error if there is some error. So from main scale reading we can, I'll just show you the, so this is the vernier caliper. The scale here is called main scale and the scale on this small thing, if you see, this is vernier scale. Okay, so whenever we carry out the measurement, again from the last time, because we are not going to repeat that portion again, when we carry out the measurement, main scale, up to main scale we can say we are sure the digit measurement is certain, whereas the last digit may have some error because we match it, right? The out of 9 or 10 which division is matching exactly, we take it and then multiply it with least count. So there may be some error depending on us, that if we are taking 2nd digit is matching or 3rd digit matching. So we usually consider that if this is the measurement that I have total reading, if I am getting like this, then we usually say that till here it's certain, but this I obtained from vernier scale reading, so it may be uncertain. We cannot be very sure about this particular decimal digit value. So significant digit means, or significant figures, whatever we call it, it is combination of reliable digits plus first uncertain digit. So like in this example, these are the certain digit and this is uncertain digit. So including these all the digits, they all will come under significant digits. Significant digit actually shows us the precision of measurement, like we talked about here, what is the precision of vernier caliper and its least count. Yeah, so depending on the least count of the instrument we are using for measurement, so we can talk about the significant digit. Now there are certain rules to find out about the significant figure in any number we are given. For example, these are the rules. Now we'll see through example what they mean. Like the first rule is all non-zero digits are significant. For example, like in this that I said 23 point, I don't remember, maybe it was 23.65 centimeter or something. So in this value, all the non-zero digits are significant. So you can see all these are non-zero. That means these all are significant digits. That means if the question is how many significant digits are there in this, then the number of significant digits will be 4 here. Then another rule is all the zeros between two non-zero digits are significant, no matter where the decimal point is. We'll see about the decimal point later. But what this means is all the zeros between two non-zero digits are significant. So okay, so guys, I think last week's assignment also had some significant assignment questions on significant figures. That's why I thought this week we'll revise about this. We had missed out on this, so yeah. Otherwise, this I think this week's assignment, I mean week 2, also has some questions based on this. So anyway, it will be useful. So based on what second rule is saying is, if say for example, after any measurement I found out values like this, it's saying all the zeros between non-zero digits are significant. That means in this particular value, the number of digits will be, number of significant digits will be 1, 2, 3, 4, 5. Here the number of significant digits will be 5. Or even if it's without decimal point, for example, say if this is the number, then again these two zeros come between these non-zero digits, so the number of significant figures here will be 4. Okay, moving on to the third rule. If the number is less than 1, the zeros on the right of decimal point but to the left of the first non-zero digit are not significant. Okay, I'll explain this. What it means is, if a number is less than 1, means if the number is something like this, it could be anything. For example, let's say it's like this. So if the number is, this number is less than 1, clearly the zeros on the right of decimal point, these two are on the right of decimal point, but they are on the left of first non-zero digit, so they are not significant. So in this particular example, if we want to know number of significant digits or number of significant figures, then that will be 2 only, not 5 or 4. Now moving on to fourth rule. The terminal or trailing zeros in a number without a decimal point are not significant. So for example, and I'll explain something why these rules are important, because say if we are taking a measurement, we got the value 123 meter. Here we clearly see the number of significant digits is 3, but right now it was in meter. What if I change it to centimeter? Then it will become 1, 2, 3 and we'll get 2 zeros in centimeter. But does that mean now the number of significant digit has changed? So no, it should not change. For that matter, these rules comply with this kind of situation, because we saw that, I mean this rule will tell us that terminal or trailing zero in a number without decimal point are not significant. So these two are not significant, and again the number of significant digit again will be 3. Similarly, even if I convert it into millimeter, there will be 3 zeros, but still the number of significant figure will remain 3. The next rule is the trailing zeros in a number with a decimal point are significant. What this means is, we can see from this example, now these zeros are after a decimal point. So now they are significant. And why actually they should be significant? I mean, because when we are taking a measurement using vernier caliper again, say, let's assume, and with main scale reading was 2.5, or I mean just say that we got 2.50 centimeter. This is the total reading. So we know that using vernier caliper we can go up to the second decimal digit, because its least count is 0.1 millimeter, that is 0.01. Does anyone have some question? Okay, I heard. Okay, unmuted. So using vernier caliper, we know that vernier caliper's least count is 0.01 centimeter. So using vernier caliper we can get precise value up to second decimal digit. So that's why this is not just like we have added, it has a meaning here. It's telling that the value is precise up to the second decimal digit. That's why this 0 here after this decimal point, this 0 here is significant. This is the meaning of this rule. And similarly, whatever this measurement value is here also. So again, we have to combine all these rules and take care that these is not significant, but these two are significant because they come after decimal point. So the number of digits, significant digits here will be 1, 2, 3, 4. Here the number of significant digits will be 4. I understand maybe it's too many rules together, but if you'll sit down and go through them one by one, you'll understand why they are like this, and you will be able to remember them as well. We have more rules. These are: for a number greater than 1 without any decimal, the trailing zeros are not significant. I think we already discussed this one. For a number greater than 1 means like 23. For example, the trailing zeros are not significant. I think we had discussed this earlier. Anyways, so here the number of significant digit is 2. For a number with a decimal, the trailing zeros are significant. I think I don't know, anyway, it seems repetition, but it's the same thing. For a number with a decimal, the trailing zeros are significant. So here the number of significant digits will be 2. So these are like the summary of all the rules based on which we decide the significant digits or significant figures in any measured value. Based on this, I had seen few questions in the assignments, so I thought it's important to go through them. We have studied these things in class 11th or 12th. I think class 11th, at least in CBSE board NCRT book, I have seen it. So you can go through that. I'll share that chapter PDF. It's given nicely there with all these sorts of examples. Now moving on to this. Okay, so this was just till now. Here we understood how to understand how many significant digits are there. Now next question is how to do the addition, multiplication using keeping significant digits in mind. For example, if I have measured some mass, I have measured some object's mass. Okay, its mass comes out to be 4.237 gram. So based on all the rules that we just now discussed, we can see that here the number of significant digits is 4. It's up to 4 significant figures or digits, we can call anything. When I measure value, I may have used some instrument for that. Based on that instrument and its least count, I found out its volume to be 2.51 centimeter cube. Here we can clearly see the number of significant digits will be 3, right? Now when I want to find out density for this object, if I simply calculate it using any calculator, we know density is mass upon volume. So when I do this calculation using any calculator, the calculator will give me values like this. Like it will do the calculation and it will give me decimal, like it may give me, depending on the different calculator, they may have different range up to which they will give me in the decimal place. But like for any random calculator, say it's giving me up to 11 decimal places. Now the thing is, use the precision or the limit of my measured value is giving me only 2 decimal digits for volume, and for mass it's giving me only up to 3 decimal digits. Then what is the meaning of getting up to these many decimal digits? Does it even make sense? So actually it's not very sensible or meaningful. So in this case, how should we then take care about that? How much up to which decimal digit should I consider the calculation, like the final value of my density? For this, the rule is, in multiplication or division, the final result should retain as many significant figures as are there in the original number with the least significant figure. Okay, so this big sentence, what it means is, that whenever we are carrying any sort of multiplication or division, our final result should have as many significant figures as there are in uh, our original as there are in original number, but which, like here when I'm dividing, one number has 4 significant figures whereas the other number has 3 significant figures, then which one I have to take? So the rule is that we have to consider the number which has the least significant digits. This has 4 significant digit, this has 3 significant digit. So in my density calculation, I will stick to 3 significant digit. Here we have so many digits right now, but based on this rule, I should only have 3 significant digits, means something like this. But we also know about rounding off, right? We also know about rounding off, that if some number is 233 say, and I can round it off to 230 if I want to round it off to 10 digit. If I want to round it off to 100 digit, then I can make it 200. This also we had discussed in brief last week, and anyway you know also, it's very basic thing. So here I can simply not drop these decimal digits, I should round it off. So this I see it's 8, it's more than 5, so if I'll round off, it will become 1.69. So my density will be 1.69, and based on rule it has 3 significant digits. So when we divide it like this, we should report the output not something like with these many decimal digits, but in this way, and of course with the unit, but it should be 1.69 gram per centimeter cube. Okay, next thing is, if we have weight of 3 objects, say 436.32 gram, another object is 227.2 gram, third object is 0.301 gram. Now here it's about addition. The last rule we discussed, that was about multiplication or division. Now what we have to do, okay, first let's calculate how much we are getting. So using my calculator, I'll see, just a moment, 436.32 plus 227.2 plus 0.301. So based on my calculation, I hope you guys would also got a calculator. From my calculation, I am getting it to be 663.821 gram. So what we can, but again the question is, here I am getting 3 up to, I am going up to 3 decimal points, but if I see this one number, this has up to 2 decimal point only, this has only up to 1 decimal point, this has up to 3 decimal point. So here I should, how much decimal digit should I go to? So it's time for our next rule, which is regarding addition and subtraction of the values. So this rule tells us that in addition or subtraction, the final result should retain as many decimal places as are there in the number with the least decimal place. So what does that rule means is that my final result should have as many decimal places as was there in the number with least decimal places. This number has up to second decimal digit, this has up to 3 decimal digit, this has up to only the first decimal digit. So my final answer will also have only, my final answer should also be till this 1 decimal digit, and even if we round off, we can see that it will round off to 663.8 gram. So just to revise again, when we are multiplying, we consider significant figures, whereas when we consider addition or subtraction, we consider decimal places. Okay, this is the difference. But both the time we were considering the least significant digit or this least decimal place value. Now this was the rule regarding the arithmetic operations with significant figures. Okay, so I think based on this little discussion on significant figure and the arithmetic operation, we can start with solving some questions. These are the questions I got from for the same course, previous year assignment solutions, like previous year assignment problems these are, and we'll discuss and see their solutions. So okay, so last time I was seeing that there were students who were writing the answers in the chats, or they were answering. So this time last time itself actually we had thought that from next class onward we'll give you guys some time, maybe one minute depending on the question, and after you guys give answers we'll discuss the solution. So this is the first question. I think you all can see. So now I'll see if you guys are putting anything in chat. You guys can solve it and answer in chat, right? So that I'll see. We'll wait 30 seconds for this. You guys can write the answer, either the whole value or the option number. Oh no. Okay, today Aditi is not there. Last time she was writing all the answers. Meanwhile, I was solving. Anita or Donald, you can write your answers in the chat. This question is not difficult, right? It's just basic rounding off. Yeah, okay. Donald has already sent his answer. Before we discuss, Anita, would you like to send your answer as well? Okay, otherwise, let me see. So Donald had answered 0.58, I think. So the question is, we have to round off 0.583 to the nearest tenth. The number is 0.583. This is the 10th digit. This is the 100th. This is the 10th digit. This is 100th. And this is the 1000th. So here we have been asked to round off this number to the nearest tenth. That means up to this place. So we'll see the next one, which is 8. It's greater than 5. That means this will become 0.6. So Donald, I think you made the mistake in understanding the 10th and 100th is. That's all right. So the answer should be 0.6. I hope you understood where you made the mistake. This is 10th digit, this is 100th digit, and we have been asked to round off this number to the 10th digit. So when I'll round off and my answer will become 0.6, this is the 10th digit. Okay. If you got confused, usually like if we write some number, say any number, this is ones digit, this is 10, this is 100, right? But on this side of decimal point, this is 10th, this is 100th, and so on. So the correct answer will be 0.6. I hope that was clear and you understood where was the mistake. Okay. Moving on to the next question. Next question is this. Okay. Now I think you understood and you will be able to answer this one. Okay. Donald has answered. Others would like to answer? I think it's easy and you have understood. If you made the mistake last time, you can answer. Yeah, okay. So both are saying it's okay. Let's see. So here the question was up to the nearest 100. So I think we already understood now that, sorry, 29.0384. So this is the 10th digit, this is the 100th digit, and we have to round off till here. This is more than 50, so this will become 29.04. Yeah, so both of your answers were correct answer. This is the correct answer. Okay, so the next question is this. I'll just read out the question once. The resistance of a wire is 8 meter long, means resistance of the wire is, resistance of a wire 8 meter long and 8, okay, so the resistance is, sorry, the question is wire length of the wire is 8 meter, diameter is 8 mm, resistance is 0.5 ohm. So what is the resistivity of the material of the wire? So you have 1 minute to solve this. Go ahead. I hope you remember the formula, like how resistance depends on which parameter, and then we have to calculate the resistivity of this material. And you can tell me the option either in the chat or again you can unmute, there is no issue. I hope the question sentence is clear. If you have any doubt, you can ask me. If there is any doubt in understanding the question. But I think I have already written all the parameters that are there in the question. You just need to do the arithmetic. Oh, so okay. In that case, don't just wait little bit. The formula for the resistivity, you know the formula for resistance? Do you know the formula for resistance? How resistance depends on, maybe from there you can find out how resistivity depends on length and area. Otherwise, okay, let's discuss this question, not anything much. So, I thought this also we have already studied in school time, that for any material, the resistance, dependence of resistance is proportional to length of that material or object, whatever we have. It's directly proportional to the length and inversely proportional to area of cross section. When we combine these two things, we get L over A, and when we want to remove this proportionality sign, we will put a constant, right? And that constant is called what? That constant is called resistivity. This constant is called resistivity. In this question, we have been asked to calculate resistivity. So Donald, do you want to try it now? Now, I hope you have understood the formula. Please try now and tell me which option is the correct one. Anita, you also try please and let us know your answer. If you want me to show the question, okay. This is the question and this is the formula, sorry. We know, right, wire, what does it look like? So you have to put the appropriate, that area is area of cross section of the wire. Is that clear? What is cross section? Or okay, let me tell that also for this particular question, that we know wire, it's very thin, but just to make it clear here, I'm making it this thick. So this is a wire of say length L, and we see at the end it's something like this. So we can compare it with a cylinder which is very thin, and the area of cross section is this circle. Like this may be the length, but this circular face that we see at the end of the wire is, we are talking about its area here, cross sectional area. So okay, let me start solving this. So from this formula, we'll see that resistivity will be R times A over L. Now area of the circle, we know area is pi r square. Here we have been given diameter. We'll change that to radius. Radius will be 4 millimeter. That means, resistance is 0.5 ohm. Area is this, and r square means 4 whole square divided by the length. The length is in 8 meter. So of course the important thing that we need to keep in mind, that either we should convert all these units in the same unit in the beginning, or we have to keep in mind, otherwise we may make mistakes here. So I would suggest the best thing is to convert this all in the same unit in the beginning. Like here it's in millimeter, you can convert it to meter. So millimeter to meter means it will be 4 into 10 to the power minus 3. It will be 4 into 10 to the power minus 3 meters. So when you will do this calculation, what we will get is, for solving this, we will get this. I'm getting pi into 10 to the power minus 6 ohm meter. Now there is no answer here with ohm, so I'll put the value of pi. So pi value is, it's a lot of decimal digits, but here at least we can go up to, I am writing up to 2 decimal digit. So the answer that somebody has joined or something, option B. Okay, don't really see your answer. Yeah, so the answer, yeah, that's correct. The correct answer is this. But this you should keep in mind, that the resistance depends on proportionally on the length, inversely proportional to the area of cross section, and the combined formula becomes something like this. Here we were asked to calculate the resistivity, and taking care of all the units should be same. The answer we get is 3.154 times 10 to the power minus 6 ohm meter. Ohm you can write with a symbol also, so ohm meter. So the right answer is B. Next question is this. The question is, when two resistors are connected in series, their equivalent resistance is 9 ohms, and when they are connected in parallel, the equivalent resistance is 2 ohm. You can start solving. Meanwhile, I am just making the diagrams. We have been told when two resistors, let's assume the resistor 1 and resistor, when they are connected in series. Okay, so this is the symbol of resistors, right? I mean, better than this, but when they are connected in series, I'm connecting another one here. So when R1, R2, the two resistors are connected in series, the total becomes, their equivalent resistance is 9 ohm, and when they are connected in parallel, again this is R1, R2, when they are connected in parallel, then their equivalent resistance is 2 ohm, and we have to find out the value of these resistors. If this is the situation, then what is the value of these individual resistance, that we need to find out. Again, 30 seconds or 1 minute, let's take it, and then let's try, and after that we will discuss the solution and how it has to be solved. So all of you can start trying. hope you guys remember what is the rule for adding when resistors are in series and when they are in parallel, because that is what we require here to solve this particular problem. Okay, I think I'll at least, if you know it's good, if you don't know then I'll at least tell that when two resistors are connected in series, the equivalent resistance becomes, the equivalent resistance is actually added like this. It will be R1 plus R2. When two resistors are in parallel, then when they are in parallel, so we do the calculation like this. It has a reason, but here we'll just straightforward go to the formula. So it's like this: 1 over R1, 1 over R2. This is the case when they are connected in series. This is the formula when they are connected in parallel, and this becomes R1 R2 divided by R1 plus R2. Sorry, I'll do this. Wait. Oh, this will be R1 plus R2 divided by R1 R2 for 1 over R equivalent. It will be like this. When I change it to R equivalent, that is reciprocal, it will be R1 R2 divided by R1 plus R2. So we need to use this formula, and here we have given that this value is 2 ohm, and here this value is 9 ohm. So we need to do some substitution, and from that we will obtain the value of R1 and R2. So you can try. Does we have any answer till now? No, not any answer till now. Okay. Is there again any specific help needed, or like where are you guys stuck? You can tell me if you want. Anyway, we have very few people presently, so if you want, like we can discuss and solve together. Where are you stuck? Solving it, or because formula I have given when resistance are in parallel and then they are in series. The formula I have given.
Ma'am, my answers only came to 1 by 2 or approximately 1 by 2. Never came to 2.
Wait just a minute. You are telling for which one? For which, what exactly you are telling me?
For option B, I have got an effective resistance of 1 by 2 on on parallel connection.
You means for this you are telling R equivalent to 2 ohm.
Yes, ma'am, I got 1 by 2.
Okay, let me do this for you. So for series you are getting, I mean you, no, wait, I, sorry, are you talking about like R1, R2 we right now don't know, right? Then we need to, what we are given is the total will be 2 ohm. Now we need to find out the R1 and R2. This we have been given. We need to, based on this information, we need to find out what is the value of R1 and R2 individually? Okay, I think if there is more confusion happening, I'll say, okay, let's solve this. I'll take the new slide. So let's do this. Okay. So what was given was, we had two resistors. When they were connected in series, they are already telling that the total will come in this situation. The total is in this situation the total is 9 ohm, and when these two resistors are connected in parallel, I hope this diagram is not confusing. I mean, what I want to draw is something like this. This is the symbol of resistor, right? So it's something like this. This is again R1, this is R2. This is R2. Here, in this case, we have been told it comes out to be 2 ohm. This is already given in the question. Now what, and we have been asked to calculate R1, R2 individually. So what we know is, when two resistors are connected in series, the equivalent is equal to R1 plus R2, whereas when they are connected in parallel, the final formula we get is R1 R2 divided by R1 plus R2. Now what we'll do is, we'll use this information and these two equations, equation 1 and equation 2, and we will try to find out the value of R1 and R2. So putting 1 in 2, we'll see that this, how it becomes as, this 2 ohm is R1 R2. From equation 1 I know that R1 plus R2 is 9 ohm, so I'll substitute that. This gives me R1 R2 is equal to 18, right? Now from this one I know R1 is 9 minus R2, right? I'll substitute this in this and I'll get R1 and, oh sorry, let's take this R1 value here, I'll put from here. So R1 is 9 minus R2. Maybe you can now actually guess also, but I'll just show what is the whole procedure. I'll substitute this particular thing in this, we'll get it like this. Now this will be 9 R2 minus R2 square minus 18 is equal to 0. So if you remember, in class 10th I think we had studied, around class 10 sometime we had studied how to solve quadratic equation. R2 square, if I'll take this all to be that side, it will become R2 square minus 9 R2 plus 18 is equal to 0. Because I'm solving and I think I have not got any answers till now. In that case I will do the quadratic equation solving also. Okay, that's okay. I'll do that also. Okay, so we are getting quadratic equation. Now let's solve this. There are, I think, 3 techniques that we had studied about in class 10, but I'll just do this particular one. Wait. R2 minus R2 square minus I hope you remember. I don't know what this method is exactly called, but we see, right? This, uh, its multiplication should come out to be this, and addition should come out to be this. Splitting bracket or something it is called. So this is this way of solving quadratic equation. When we'll take common, we'll get r2 minus 6, and this gives us r2 minus 3, r2 minus 6, right? This implies that value of r2 can either be 3 or it can be 6. Both are possible. It can be 3 ohm or it can be 6 ohm. If we consider R2 to be 3 ohm, from this particular equation 1 we can clearly see R1 will become 9 minus 3, that is 6 ohm. If I consider R2 to be 6 ohm, then again from equation 1 R2 will become 9 minus 6, that is 3 ohm. So our answer will be 6 and 3. Like, they are not asking which one is what, but the thing is, we are talking about two resistors. Any one of them is 6 ohm and the other one is 3 ohm, or vice versa. So this is our answer. So the correct answer here will be 6. Okay, now I just want to know if this thing is clear or not. Put in chat, or you can answer also. I want to know if this solution is clear to everyone. Yeah, why is it like this when I'm asking something? People don't want to answer and leaving. Yeah, I'm just asking if the solution is clear. Is the solution clear, or you want me to repeat something? Is it not clear? Is it clear? Anita, Donald, Ganeshan, you were there last time as well, right?
Yes, madam. I was there.
Yeah. I wish you would have joined earlier. We discussed about rounding off figures, rounding off and significant figures. If that is
Okay.
clear with you, it's good. Otherwise, we had discussed that.
Yes, madam. It's clear, madam.
Okay. Donald, do you have anything to say? Or then otherwise we can proceed to next question.
Nothing, ma'am.
You can proceed.
Okay. Okay. Wait. Okay. So this is the answer for this question. Now moving on to the another question. Okay, here we have been given a connection of 4 resistors. Values are also given, and we have been asked to find out the equivalent resistance between A point and B point. Okay, again I am giving you 30 seconds so that if somebody wants to calculate and do, they can put the answer in chat. After half a minute, I'll start discussing the solution. So you can start trying. Firstly, you need to, I think, make a equivalent diagram, like which is more clear and which can help you in finally calculating it easily. This looks complicated, but it's not. You just need to simplify this figure little. No answer still now. Okay. Okay, in that case, let's start discussing. If there are no answers yet, that's okay. Let's see how it has to be done. So, we have been given 4 resistors which are connected in this particular way. Let's try to simplify this. We'll make an equivalent diagram. I'm not changing position or anything, but I'm just simplifying this. So between A and B, these see, I'll try to change connection of these two. Not connection, I mean I'll just redraw. So from the point A, see, this is just okay. This is just a wire, and we are given that connecting wires have 0 resistance. That means this is not a resistor. So I can directly take, I mean, even if I'm increasing the length of this particular wire or not, it doesn't make any difference. It's just that it has been drawn in that way. So it means that from point A, there is one resistor of 10 ohm from this point. There is one more resistor which is connected like this. So only difference, instead of saying that the resistor is like this, they have made it that the resistor is like this. That doesn't matter. The resistor is still the resistor, its value will still be same. It's just how they are drawing, because it's a question, they are making it a little complicated and we are trying to simplify it here. So this is one. The another one, again the 10 ohm that is connected here, and at the end we can see they are connected together. So same way I'm connecting them here together. So I'm connecting them together. After that, from this point there is one 20 ohm resistor that is connected to point B, right? This is connected to point B. This is 20 ohm. Again, from the same point there is another 20 ohm resistor which is again on the other end connected to B. Okay, so don't get confused about this also. I mean, I can make it like this also. There is nothing going to be different. This is same. It's like one point. Anyway, they have said that apart from resistor, everything else has 0 resistance. I can make it like this also, or a point also. It's all same. It's like connected at a particular point. So if you want me to draw like this, then this is it. This is B, this is A, and the values are like this: 10 ohm, 20 ohm. So as we had discussed in previous question, when two resistors are connected in parallel, the direct formula we knew, it's R1 R2 divided by R1 plus R2. So what we'll get here is 5 ohm. I think we'll get 5 ohm. Yeah. Similarly, when I'll calculate equivalent resistance for these two resistors connected in parallel with the same formula, you will get the resistance 10 ohm. Now we'll again redraw this figure. Between this A point, I can replace this 10 and 10 ohm resistance in parallel. I can replace that with a 5 ohm resistor. This is 5 ohm resistor. This 5 ohm resistor connected connected with another resistor of 10 ohm. Now we know when two resistors connected in series, these are, so the total resistance between A and B will be 15, right? 5 plus 10, 15. So the correct answer here will be, correct answer will be 15 ohms. Okay, moving to the next question. Yeah, so the question is very simple. The question is, resistivity of a wire depends upon mass, area of cross section, volume, or temperature. So does anyone know answer of this? We had discussed earlier also, if you remember, in that particular formula, dependence of resistivity of a wire. Oh yeah, I know. Okay, let's see. Do you remember resistivity is a, okay, first let me see if any of you want to have some, give some answer. If there is no answer, okay, let me tell. So resistivity, if you remember, I had told that resistance is parallel to length and inversely it's directly proportional to length and inversely proportional to the area of cross section. And when we replace this proportionality constant, we replace it using this constant that is called resistivity. Right? This is called resistivity. Resistivity is a constant for any particular material. For a particular material, value of resistivity is constant. But it does not depend on mass. It does not depend on mass. It does not depend on area of cross section. It does not depend on volume, but it depends on temperature actually. Here, resistivity of a wire. Wire, we have not been told what exactly this wire is, metal or insulator or conductor or semiconductor. But what happens is, for metal, resistivity increases when we increase the temperature. When we increase the temperature of a metal, resistivity also increases. Whereas for semiconductor or insulator, it's the opposite of this. There is reason behind it. We don't need to go in detail right now. If you are interested, I'll tell you. You can ask. But otherwise, so what we know is resistivity does not depend on mass, area or volume, but it does depend on temperature. So the answer for this question is this: resistivity depends on temperature. The next question is this. There is, okay, so I think this is also, oh, here the question is, resistance of a metal wire is increased. The statement is, resistance of a metal wire is increased by increasing its length, area of cross section, temperature. Again, first thing we have to do is write the formula of resistance. After that, it will be easy for us to answer this. Okay, so resistance depends, this is anyway constant. It is constant for any particular material. But we can see that if I increase length, resistance value will increase. If I decrease area, this will increase. That means if I want to increase the resistance, then I have to increase the length and decrease the area. That means the question is asking what I have to increase the resistance. What I have to increase. So if I'll increase, the resistance will increase. Area of cross section, if I'll increase, then resistance will decrease. So this is not the correct answer. Temperature, so okay, if we increase this formula is applicable at particular temperature, at some constant temperature. If the temperature is increasing, then resistivity will, because it's for metal wire, temperature is increasing means this resistivity will also increase, and then the resistance will also increase. So this parameter is also correct. So our answer is 1 and 3. So 1 and 3, these things. Does any of you want to know anything? Is it clear? Anything in detail? Anything specific? Why it's like this? No? Okay. Then we can move forward. If it's clear then. Then moving on to next question. The question is, a current carrying conductor produces magnetic field around it. The magnitude and direction of field can be determined by means of a law known as which law? So actually, let me tell you this. When we have a current carrying conductor, say like it's a wire, it's carrying a current I, and we know that when charge flows, that is a rate of change of charge, that is current, right? So when there is a current flowing in a wire, there is magnetic field around it. There is magnetic field lines around it because of that current, and the magnitude and direction of the field, this is given by a law called Biot-Savart law. Okay, so this is the correct answer. Moving on to next one. So here the question is, a very long straight conductor carries a current of 20 ampere. A very long straight conductor carries a current of 20 ampere. Here it's given. Find the magnitude of the magnetic field at a perpendicular distance. This is the perpendicular. This is the perpendicular distance here. At a perpendicular distance 20 centimeter from the wire. We have to find the magnitude and magnetic field. So as we discussed, from Biot-Savart law gives us the magnitude and direction of the field at any point at distance from this current carrying conductor. So what that formula is, that the magnetic field at any point, like here at point P, the formula is, there is a derivation which we don't need to go into right now, but the formula is like this: B is equal to mu naught upon 4 pi I by it's okay, I'll tell you how this comes. Like, wait, let me tell you this. Yeah, so like this is the question, but what the Biot-Savart law is like, if this is a current carrying conductor of current amplitude of I. Does anyone have something to say, or?
So,
Excuse me, some mic is on. Do you have something to ask, or is it a mistake? Anita, your mic is on. Josh, your question is, wait, what was your question? The questions in week 1 assignment were not discussed in week 1's recorded classes. Josh, so okay, let me tell you how we do this. Week 1 assignment, if you remember, the deadline is 7th August, I think. Yeah, so week 1 assignment, if you will check, the deadline is 7th August. So we are not supposed to discuss those questions. Anyway, I mean, 7th August is the deadline. So what we can do is we can give you some different questions which are similar to the questions in the assignment. So in these interactive sessions, what I'm trying to do is I am trying to do the questions of previous year. Like previous year when this course, experimental physics 1 course was taken, that time week 1 those topics were not discussed in week 1, those topics. Okay, so what are those topics that I missed? I think I missed the significant figure that I discussed today. I don't know you were there or not. Can you tell me what exactly are those topics so that I'll come to know about? Josh, can you please tell us what were those topics? Is it like you don't remember or something? Oh, okay. I think, okay, so let me say, I think what you want to say is that what the Professor Das is teaching is little different from what he are the questions in assignments, right? Did you mean this? Can you confirm if this is what you mean? That what he's teaching in the lectures are little different? Yeah, okay. Thank you for answering. Okay, I understood. So, yeah, so, okay, let me tell you about this course. So, it's very elementary basic experimental physics course, okay? So, most of the things we have what I am trying to do in last session also and this session also is they are already we have studied them in 11th 12th physics. In fact, in the beginning of today's session I was telling that you can get the these there are no particular recommended books and you can get these relevant things in NCRT chapter 1 chapter 2 of class 11 12th textbook. That is the best source I would suggest, because last time also one student Aditi was asking for the recommended book for this particular course. So she has shared a link which is there in the course website, but that book link is actually the video transcript. It's not any particular book, it's just the transcript of that lecture video. So the best books to read for this is the NCRT PDFs that I'll be providing. But okay, so what Professor Das is doing, he is just showing you those things, but I mean he's showing you galvanometer is working and those things, but the questions are little different, because in experimental, like, he's teaching you how to that this is vernier caliper and these things, but those basic things we are supposed to be knowing already actually. So that's why the questions he is giving you and we are supposed to study it, either we should remember or you are supposed to look for them somewhere. Yeah, I can see like little bit the lectures are slightly different from the kind of questions. So that's why I think what I'm trying to do in this session is I'm trying to cover the topics so that you will be able to answer those questions in the assignment. Like last time I missed to talk about significant figures, how we identify significant figures in any value. So, but I saw that those based on significant figures were there in last week's assignment also and this week's second week's assignment also. So that's why I took up that topic this time. But like in the video lectures, they were not covered in detail. So if like I think it will be good for you, helpful for you to solve the assignment questions if you attend these sessions, like so that, yeah, I think if you attend these sessions, I'll try to cover those topics which will help you in assignment. This is for everyone, but thanks for asking this. Thank you, Josh. Okay, so, and like this is why today, like few questions we did on rounding off and significant digits. Now the next portion I was going to do is ammeter and galvanometer, because based on that also there are questions in the assignment. So next we'll do that, but let me solve this first. Okay, this particular question. So we were talking that based on the Biot-Savart law, the law says that if there is a current carrying conductor, it is carrying current I, then at some point, say A, what it will tell us what will be the magnetic field. If the perpendicular distance between this point and this conductor is say R, and if the angle subtended here is phi 1 and the angle subtended by the second end of the wire is phi 2, there is whole derivation but we don't need to go into this. The length, let me write it here, the length, the perpendicular distance of this point of interest from the wire is R. Then the formula is this, that the magnetic field at this particular point will be mu naught over 4 pi I over R sine phi 1 plus sine phi 2. Okay, so now for this particular question, what we have been asked is a very long, this is very important, a very long straight conductor carries current of 20 ampere. This is like they have given. So if what's important for us is that if we take the conductor to be very long, if we take it to be very long, infinitely long, then this phi 1, you can see, right, if it's the length is this, then the angle is phi 1. If the length will increase, the angle will increase, and if it goes to infinity, then this angle will increase and it will become 90. We assume that it's infinitely long, and here also is given very long, means we can think that it becomes 90. So this phi 1 will become 90. Similarly, this other end also is very long, so this angle also we can assume to be 90, and we know sine 90 is 1. So how this formula will change is mu naught over 4 pi I over R, and 1 plus 1 will be 2. So the B will be mu naught over 2 pi I is given to be 20 ampere and the perpendicular distance R is 20 centimeter. So when we will calculate this, we need to change this, and somebody is in. Is anybody trying solving? Otherwise, let's solve. I have given the formula. If anybody is solving, you guys can put the answer. Otherwise, I am anyway going to. So when you will change this centimeter to meter and put the value of mu naught, so the value of mu naught, let me write somewhere, the value of mu naught actually is, its permeability of free space, it's given by 4 pi times 10 to the power minus 7 Tesla, Tesla meter per ampere. This is the value of this. When you substitute this and convert this, calculate this, you will get the answer is this. So our correct answer will be this. This is the answer for this question. Okay. Moving on to other question. This question, I think it's similar. A current of 4 ampere is flowing in a wire of length. Okay, let's draw the diagram. There is a wire of length is 0.5 meter. Current of 4 ampere, and the current is 4 ampere. It is placed in a uniform magnetic field of 1.5 Tesla. Okay, this question is different from the last one, and in it's this particular wire is kept in a magnetic field. The value of magnetic field is 1.5 Tesla. The angle between the direction of magnetic field and the direction of current is 0 degree. The force acts on the wire. Okay, so for this we know the formula. Then that force acting on a current carrying conductor when it is kept in a magnetic field is given by I dl cross B. That is the and then we'll change this, this is what we call cross product, right? It means B sine theta. This can be the small d, dl means small length element. Either we can just call it length also, that's fine. I will be sine theta. So what we have been given here is that the direction of magnetic field and direction of current is 0. That means B and I are in same direction. That means theta is 0. So sine theta will be 0. That means the force will be 0 here. And force is given in Newton, but anyway it's 0, so doesn't matter. So here the answer should be 0. Next question is, a charged particle enters along plus x direction. A charged particle enters along plus x direction with velocity v in a region where a magnetic field B acting along plus y direction. Okay, let's do this with right hand rule. Let's keep it like this. This will be better. This is the correct way to, yes. They are all perpendicular actually. So the charged particle is going along x direction with v velocity, and magnetic field is along the y direction. The particle will experience, they are asking about the force, what force the particle will experience in which direction. Now we have another concept which tells us that force on a moving charged particle is given by so this is the formula that tells if there is electric field also and magnetic field also, then the total force acting on that charged particle is this. But in this particular question there is no electric field, so we don't need to think, this contribution is 0. And now this, so here we have not been asked about the magnitude, they have just asked about the direction. So direction of velocity is in x plus x direction, magnetic field is in plus y direction, and we know that cross product means the resultant will be in the third direction. Cross product, because if it's x dot x, it will be x cross x, it will be 0, right? Cross product we know, if x in x cap y cap, cross of that will be z direction. So the force will be exerted on the particle in plus z direction, cross product of x direction, y direction will be z direction. So the charge particle will experience force, and the force will be along plus z direction. It will experience the force along plus z direction. Okay. Now we have one more question. The question is, we have two parallel plates. These are those, sorry, let me, this is one plate, this is the second plate. These are two parallel plates, each of length L, and they are separated by, distance between them is 2d. Now the next thing is, uniform electric field acting between the plate is E. There is electric field between these two plates of magnitude E. A charged particle of charge Q. So again we have a charged particle, its charge is Q. Its charge is Q and its mass is m, and it's passing along straight line at the middle of the plate. So the particle is passing from the middle of between these two plates. That means if this is total 2d, that means this will be d. So the particle is starting from the middle, and let's see where it goes. Middle of the plate with velocity u as shown in the given figure. The minimum value of this velocity to cross the plate without hitting them. Okay, so from the previous question, like we saw that whenever a charged particle is present in the presence of electric field and magnetic field, there is force it experiences. Okay, in this case there is no magnetic field, that means contribution of this portion is not there, but what we have is this. If there is no electric field, the particle is anyway crossing with some velocity and it will keep on passing. But since there is electric field in this direction, the particle will experience a force. The particle will experience the force. This will be the value of that force, and the direction will be along E. Means it will start from here, middle of the plate, but slowly it will go in this direction, that is along electric field. But the question is asking us, what should be its minimum velocity so that it crosses the plate without hitting? Means of course it's experiencing force and it's deviating from this path, but how much should be its velocity so that instead of hitting the plate it passes before hitting the plate? So for this, okay, let's do things step by step. I think I can draw again this thing here. Let me do this. These are two plates. The length is L. Distance between them is 2d. The charge is starting from the center. That means this distance. Okay. The charge is starting from the center. That means this distance is d, and it's supposed to go like this. But since there is electric field, I'm not drawing this electric field inside because I want the figure to be clean, but there is electric field as was given in the question. There is electric field between these two plates. So since there is electric field, the charged particle will get dragged like this, and we want to know what should be its velocity so that it does not hit the plate but just passes. So we will see what is the acceleration or the force on the charge in, let's assume this is the x direction and this, let's say this is the y direction. So we'll see what is the force acting on the particle in x direction and y direction. So we know force is mass times acceleration, right? So mass is this, and what is its acceleration in x direction? We know the velocity, the initial velocity. So the force in x direction is rate of change of velocity per unit time, right? Now what is the force acting on the particle in y direction? Now in y direction we already know from that formula that force acting on the charged particle is this, right? This is the force. Force is mass times acceleration. So this is the force acting on the particle in y direction. So this is in y direction. Now another thing that if you guys remember, there are three equations of motion. Let me just write it here. There are three equations of motion, if you remember. V is equal to u plus at, where this is final velocity, initial velocity, acceleration, time. The another equation of motion is s is equal to ut plus half at square. Third is v square minus u square is equal to 2as, where s is the distance actually. So these are the three equations of motion we have studied about. Now using this second equation of motion, what is the distance traveled in y direction? So the distance traveled in y direction, initial velocity, the formula is this, right? The second equation of motion formula is this, and I want to know in y direction what is the distance. So initially velocity in y direction is 0. The particle is just going in x direction with velocity this much. This is in x direction. So in y direction the velocity is 0. So we are left with this, and the acceleration is y direction. We see from here that acceleration in y direction is qe by m. Putting that, I see qe by m and t square. Now from here we see that so we know, right, velocity is distance upon time, right? If the particle is going from here to here and its velocity is u, it's supposed to cover the distance of this plate length in what time? Say some time t. From this relation, t is L over u. Using this relation, that in time t the particle will cover this much distance. Putting that here, I'll get qe over 2m L square divided by u square. Now what is this distance s? So the question had asked us that the particle should not hit the plate. Okay, the distance between plate is d and it is at the center, so this distance is d. It should not hit the plate. That means the maximum distance it can cover in y direction is d. This distance should be actually less than d, but the maximum distance it can cover in y direction is d. So if I put d in this particular equation, I want to find out the value of u actually in terms of these parameters. So that what should be the value of u, so that the distance covered should not be d. That means the charge should not hit the plates. So when I using this condition, when I substitute d in place of this s, I get qe L square divided by 2m u square. After rearranging this, we'll get u square is equal to 2m d oh sorry, this D is, yeah, actually, correct. 2md. Is there some, okay, sorry. The u square will be QE L square divided by 2md. So the answer from our option is, okay, it's in term, I need to tell the u, right? So that u will be square root of QEL square divided by 2md. QEL square 2md. I think first this is the correct answer. So the velocity, initial velocity or the minimum value of u is this, so that it crosses the plates without hitting this side of the this plate. So the correct answer is option A. Let's see. Donald, should we continue, or because I mean I have more things to say, but only since you are there, so I want to know, should I continue or this much is fine for today? Maybe in the next part we can cover next time, or I don't know. Do you want to say something? Is it clear till here? The next is actually I wanted to start talking about ammeter and galvanometer, and based on that I wanted to do the question. Anything to say? Or we can take this next time. Or let me solve it. That's okay. I'll complete this because it's important for this week's assignment actually. So let me at least teach this concepts. So actually, as it was given in the video lectures, the professor was talking about a device called galvanometer, right? So galvanometer is a device which helps us in detecting the current direction and the magnitude of current in a circuit. Like if we have any circuit, if there is some resistor, there is some battery, and if we put a galvanometer in that circuit, then like there is a resistor, there is a voltage source, so there will be current in this, right? From Ohm's law we know there will be current in this circuit. The direction of this current will be given like using this galvanometer device. If we connect it in the circuit, we'll get to know what is the direction of current based on the deflection. This was all explained in the lectures by the professor properly. Here I'll just proceed to tell how ammeter, we make ammeter using galvanometer, and how we make voltmeter using galvanometer, and then we'll try to do some questions. So this is what a galvanometer is, but we know that galvanometer will have some of its resistance. It will come with some resistance. In this particular, this is some resistor. If I want to find out what is the current in this circuit, then if I want to find out the current, it should be V by R. But if I add galvanometer in this circuit, it will give me, I mean, say its resistance is this, and this resistance is this, and the current flowing is I. Now the problem is here, now in this circuit we can see that there are two resistors instead of just R. Now the current is changing. If I want to know the direction of current or the magnitude of current, and I am putting this device, is changing the original current. Voltage is same, sorry, voltage source is same, but the resistance is actually becoming this. So the current is changing. So the problem with this is that I want to measure the actual current, but when I am trying to measure it by putting this galvanometer, the current is changing. That means I will not get the original current value that I wanted to obtain. So how to overcome this kind of situation is using this device called ammeter. How we make ammeter is, this is the symbol of galvanometer and this is the two terminals like I had shown in previous diagrams, I think. Yeah, wait. Yeah, this is a galvanometer, this is positive and negative terminal. Okay, so these are the terminals, and yeah, so these are the two terminals of a galvanometer. And when we connect a shunt, in parallel with the galvanometer, what is a shunt? So shunt is a very small resistance. Shunt is a very small resistance which is connected, it is connected in parallel with the galvanometer. So what happens is, first of all, it's very small. Second, it's connected in parallel. Now earlier we discussed that when we have two resistors in parallel, like here it's one is this galvanometer, another is this shunt, and they are connected in parallel, we know the total resistance will be, resistance of galvanometer, which is Rg, actually Rg times S divided by Rg plus S. Now the value of S is very small. That means this can be ignored and the value will remain Rg. And this is like, it's very small means it's around like 100 milliampere or microampere or smaller. So this total value will be less. The total value will be S, and S is very small. That means the equivalent resistance of this combination is smaller than the resistance of galvanometer. Now that means when we'll put this kind of device in the circuit, here when we were putting galvanometer, the current was changing, but when I'll keep this kind of arrangement instead of here in series, the change will be, this will be replaced by shunt resistance, and shunt resistance is very small. That means this will become, actually the I prime will be V by R. It will be approximately same because S is very small. That means I am able to maintain the same current. That means when I am trying to measure the value of current by putting ammeter in the circuit, I am able to calculate, I am not changing anything in the circuit, and I will be able to measure the value of the circuit. So this is the benefit of connecting a shunt in parallel with the galvanometer, and this arrangement is called ammeter. Now another thing is voltmeter. Okay, and so ideally, like here I am saying the shunt resistance is very small, but for ideal ammeter, ideal ammeter, the resistance should be actually, for ideal resistance should be 0. Okay, next thing, voltmeter. When I want to know the voltage drop across any resistor, like again this is a circuit, this is a resistor, this is a simple circuit, and I want to know the voltage drop in across this, then I will connect a voltmeter. This is how we measure. How we make this voltmeter? For this, we take a galvanometer and connect a very high resistance in series. Very high resistance in series. What happens in this condition is that the total resistance becomes R plus Rg, and we know from Ohm's law, we know V is IR, right? So I is potentials, this voltage source, and the total resistance. Total resistance is this. Now, as I told that the resistor that we have connected is very high value, that means this R plus Rg is equivalent to V over R. That means it's not considering Rg. So the current the current is remaining same. That means whatever voltage I want to measure will be same. So this is the concept of a voltmeter. And if I want to see what will be the value, just wait a second. So if it's point A and I have a galvanometer here, and this is point B. So basically it's an arrangement like this. These are in parallel. So some current is going here, say I, it's coming out from here. Now the current will split, right? The current will split, say Ig is going from here, and remaining I minus Ig is going from here. Now we know when two resistors are in parallel, the voltage drop is same, right? So voltage drop across here will be IR, that is Ig and the resistance of the galvanometer, which will be equal to the potential drop here. The current is I minus Ig times R. So the resistance of this resistor will be I minus Ig, resistance will be Ig Rg divided by I minus Ig. This formula is also very important so that you guys will be able to solve the questions further. I have some more questions, but like we can solve one, I think. Like this one, a galvanometer of resistance 99 ohm. So the resistance of galvanometer is 99 ohms, is shunted by very small resistance. So shunt resistance is 0.1 ohm, and converted into ammeter, resistance of ammeter will be. So we know that galvanometer and shunt are connected in parallel, right? And we know the parallel arrangement, the formula becomes this. So the total resistance will be, if I calculate this, I am getting this. Answer is, I am getting 0.099 ohm. So the correct answer is this option. So the correct answer is this. So in similar way, you can solve the other questions and it will be helpful for you. Okay, so related questions we will solve next time. Okay, so I am ending this class. Okay, thank you.
Thank you, Miss.
Thank you.